Hello and welcome to the right angle. The last time we did some exploration about shapes. It was regarding a 45-degree right angle triangle. So other than the right angle, the other two angles of the triangle each were 45 degrees. We shall continue to explore a little more about a shape like that. As a quick reminder, so what we had done is we had started with a rectangular piece of paper and we created a square out of that simply by folding. We chose any corner and folded it down somewhere there so that this edge turns and lines up with this edge, which basically means that this side comes down like this here, and so this would be equal to this, and we make a square like so. I'll fold it quickly for you. You can see this at leisure in the previous video where I explain it at a more relaxed pace. We tear this out and we have a square. But what we did next is the way we folded it, we left the fold as it is and creased it here, and so we obtained a right angle triangle. This is 90 degrees because this corner was one of the original corners of that rectangle. So all corners, each corner of a rectangle is 90 degrees. So this is 90, and we showed how this is 45, and therefore that is 45 as well. So let's see what to do next. So I got another triangle like that. This is 45 degrees on each of these corners, 90 degrees there. So I'm going to take a larger piece of paper, and the way this is done is you can see a semicircle there, and what I did is I had measured it in advance. So this line here, which is the diameter of the semicircle, matches with the hypotenuse. This is called the hypotenuse. For a right angle triangle, hypotenuse is the longest side which is opposite, directly opposite the right angle itself. So the hypotenuse matches up with this diameter. So it is the same length as the diameter, as you can see. So there you go. So that's the same length as the diameter. So I created a semicircle with a diameter, the length of the hypotenuse, drawn a circle. Now the interesting thing is, if you actually make this triangle upright and you place it with the hypotenuse on the diameter, you will find that the right angle tip of the triangle comes exactly onto the top part of the semicircle. And this should be no surprise actually, because if this is the center and this is the radius of the circle, so all points on this semicircle, or for that matter the circle, if you draw the full circle, will be of equal distance from the center. And this right angle triangle, which is of 45 degrees, if you take the hypotenuse and put a dot in the center and join there, you can actually fold over there and you get another right angle triangle which is also of 45 degrees. So another thing, and in your geometry box you will have set squares of this shape. So you can just fold a 45 degree right angle triangle onto itself, so that the 45 degree corners come right onto each other and form a smaller, actually it's half the size, it's half the area. Maybe we'll show how it is half the area another time, but and you can keep going on indefinitely, and you can make smaller and smaller right angle triangles which are of 45 degrees. Now if you see this, you know that this side is the same as this side. So when you open it up, this side is coming on to the center, as you can see. So this length is the same as this length, and of course this length, because when you fold it, they are coinciding exactly. So they're all the same length. So that means if you hold this as a center, all these 3 points are of equal distance from here. So that's like a circle. You can draw a circle on this. So that's an interesting property of a right angle triangle of 45 degrees, and you can place it inside a circle, and the right angle will touch exactly the tip there. There are similar properties for triangles. When you right angle triangles, if you draw a right angle triangle with a hypotenuse on coinciding with a diameter, then you will find that even if they're not 45 degree angles, the tip will touch the circle. But that's a different theorem. We'll cross that bridge when we get to it. So this is the little exploration for today. And 45 degree right angle triangle is the only triangle you can keep folding exactly into half its size indefinitely.